Let me share my screen.
Yeah.
If you are able to see my screen, please. If you are able to see my screen.
Yes, Deepak, I'm able to see.
So, what do you understand from security and access control?
Okay, I'll tell you. Okay. Security, yes, is nothing but protecting our data from malicious entry or somebody manipulating it, or protecting our data from unauthorized users, or protecting our data from our competitors. So that is nothing but security. Coming to access control, yes, access control is only the authorized persons are allowed to have the access to the data. Unauthorized persons are not allowed. So we authorize, uh, we give control to certain people who are involved in the project or who are supposed to use the application. So only they can go inside and then play with the data. Others cannot. So this is what is on the brief, on a general this one. This is security and access control.
Yes. So, means when we talk about security,
Yeah.
means and if you want to achieve this security, then you start from a designing itself. When we are
Yes.
designing our system,
Yes.
then we start from there only.
Yes.
And if let's say you want to make this secure, first
Mm.
first thing first, you
Mm.
need to know
Mm.
means how you are transitioning, means how you are, yeah, how your this transitioning is happening.
Mm.
Am I
Mm.
right?
Mm. Mm.
From one service to another, one
Yes.
component to
To
another,
another.
front
Yes.
end to back end,
Yes.
or back end to server.
Yes.
And for that, you need to identify those boundaries first.
Correct.
After identifying the boundary, you
Mm.
need to apply some, you can say, rules
Mm. Mm.
there.
Mm.
Means based on these rules, you
Mm.
can make it secure. Am I
Right.
right?
Right.
And there are, you can say, as I told you, and we discussed so many things. Means we cannot think. Means every rule is applicable everywhere. No,
Correct. Yes. Yes.
as per the situation, as per the context, we
Mm.
need to update our rules as well.
Mm.
Maybe
Mm.
based on you can say, take an example of restaurant itself. When
Mm.
manager is talking with the housekeeping, when manager is talking with the you can say this chef and waiter, then he use a different tone.
Mm.
He
Mm.
use a different language, stuff like that.
Yes.
So, because based on the level of understanding, based on the things, whatever we are transferring between those,
Mm.
it's changed.
Yes. Correct.
And based on that, we need to understand that as well.
Correct.
Okay. So it's a crucial thing.
Mm. Mm. Mm.
And for that, so that when it's evolved from a design
Mm.
itself,
Mm.
then it means moving forward, we need to take care. Means another team can also take care of this.
Mm.
If we
Mm. Mm.
will from a designing, if we miss that,
Ah.
then means it's carry forward and maybe when you can say some bug occur, then we will identify that,
Mm.
which is
Mm.
not a good thing.
Mm.
We
Mm.
need
Correct.
to think in our design itself.
Design. Yes. Correct.
Okay, so first we need to hear this a term. We need to identify trust boundaries in a system.
Ah. Ah.
Okay, trust
Right.
boundaries are things like say means how means components are interacting, how
Mm.
services are interacting, how
Mm.
different part of the you can say system is attracting,
Correct.
interacting
Right.
with
Right.
each other.
Right.
Am I right?
Right.
What is the medium there? So everything we need to consider for trust boundary.
Mm. Mm. Mm.
After trust boundaries, second point is authentication and authorization, which we discussed already,
Yes,
means authentication which check validate it's a
validate.
valid user or not
Yes,
with their credential. Like
correct.
somewhere we will use email or password, somewhere we will use MFA, multi-factor authentication. So it will
Mm.
validate.
Yes, yes,
And after validating means after validate only just authentication or one verification is not enough.
yes, correct.
We need to apply, you can say, each and every steps whenever
Mm.
he is going to do something.
Mm.
Then he need to, you can say this. He
Mm.
need to tell us,
Mm.
yes, means
Mm.
I am a verified user.
Mm.
So he or she will send us a authorized token.
Mm.
Okay, and in our authorization token, and apart from that, system also have a means different thing based on that we can say, hey, this person can access only this room
Mm.
or that room. It,
Yes,
user don't have access of the whole the means campus. No,
correct.
based on a role, it
Mm.
he is, you can say, have a specific you can say area
Correct.
where he is able to visit, he is able to sit and do his or her work. Am I right?
Mm.
It's not means allowed that he can go to the IT room or server room, no,
Yes,
or electricity room, no.
correct.
Okay, and we need to think about a lease privilege, which we discussed already.
Yes.
Lease privileges means, let's say for lease privileges, we will can give a access. If let's
Mm.
say we will introduce a new user, so
Mm.
we can lease privilege we can give
Mm.
to that is read only.
Right,
So
right.
they can read only,
Ah.
and whatever data
Mm.
they have their own,
Mm.
we can access to the user to modify or do the changes for that data,
Ah.
not for the other
Other
data.
data. Yes, correct. Right.
Okay, this is least privileges.
Mm.
And data protection consideration. So means, as I told you, when we are transferring from data through network, through you can say protocol, then
Mm.
there should be a, we need to take care of
Ah.
this time, because during that transfer someone can steal,
Mm.
someone can hack or
Mm.
steal our data. So how
Mm.
we will protect that? For
Mm.
protecting that, you have a different, you can say, terms or different means methods are there which you can use.
Right.
Okay, in this you can consider encryption, decryption,
Mm.
encoding, encryption, which will where we will say, hey, when we will transfer our data, first we will encode, and wherever his data is going to receive,
Mm.
am I right, or delivery is received, they know
Ah.
how they can decode this data.
Right.
Okay, so
Right.
there you can they will decode with the help of that pattern, and
Mm.
they can whatever it means we send as well
Mm.
get that information. And
Mm.
in a financial transaction or thing, they will use masking
Ah.
or
Okay.
confidential data.
Ah. Okay.
In a masking, what they will do,
Mm.
they will not user meanwhile transferring, they will not transfer same data, exact data. They
Oh.
will hide some data.
Okay.
Let's say last four number of mobile number you are able to see.
Ah. Okay.
Rest means first six number you are not able to see.
Ah. Okay.
This is called masking.
Okay.
And another part which you can think of as security
Ah. Token.
tokenization.
Okay.
In this, you can say rather than sending a, you can say actual data, they will send in as a form of token, like
Okay.
your credit card or these things. They will send in a token.
Okay.
You understand my point?
Right, right, right.
So those things should be there,
Mm.
and encryption at
Encryption.
rest and in a
Mm.
transist, which we
Mm.
discussed, touch upon on this topic.
Right.
So these are the basics. Means in a basic, whatever we covered, we will go through that. Means communication and tamper proof is there.
Mm.
Replay attack. Okay,
Right.
so service to service authentication means when we are communicating, then every service have their authentication mechanism.
Mm.
Only just if user have a, you can say, access only for, if user is entering into a company, doesn't means he will get access of everything.
Yeah, correct. Correct.
When he is means moving from tower to tower or floor to floor, access has been changed.
Change it.
Then we need to apply that access.
Mm.
Okay, so whatever we, and for designing security, so today
Mm.
we will discuss about these things only,
Okay.
how we can do that. Okay.
Okay. Okay.
For this, for your understanding, I will explain you
Ah.
these things,
Mm.
but today we will go through this.
Okay. Okay.
So could you take that up?
Yeah.
Do I need to increase the font size?
Ah, no, it's okay. This is okay. Because this is more than enough.
Okay, go ahead, please.
Okay. Trust. Sorry. Okay. Fine. A trust boundary is okay. Trust boundary system. Okay. Trust boundary is like a security checkpoint. On one side, the system cannot fully trust what is coming in. On the other hand, the system must decide whether to allow, reject, or inspect that request before it moves further. Okay. Like this we can say as authentication, Deepak. Like I authenticate whatever entries are done, we authenticate first.
You can say, let's say, means as I told you, we have a parties are there. Am I
Ah,
right?
ah,
Like in a party, we can consider front end is a
ah.
one party, back end is another party.
Okay,
Am I right?
okay,
And you can say third payment gateway with a third party.
okay,
And if you are using some external API, that's a fourth party.
okay, okay,
Am
okay,
I right?
okay, okay.
When means we are, even though we are protecting, our system is, you can say, well defined and everything.
Ah,
But if there is a scope from
ah,
a front end,
ah.
they can, you can say, send wrong information.
Okay, okay.
That's also a risk for, you can say, the security, concern of security. Makes
Ah,
sense.
ah,
You can think of, means you will, means using every, you will take a every step to make your system secure or your house secure. You will
ah,
apply, you can say, CCTV camera, you will apply, you can say,
oh,
this sensors,
ah,
everything you
ah.
apply.
Okay, okay,
But your neighbor is not, means neighbor is not doing anything. Am I right?
okay, okay, okay.
And he is, you can say, he have access of your this, he can communicate, he, you have a close relationship, and you both guys are communicating.
Okay, okay.
If he is not taking care of his security, then it's also risk for you.
Right, 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 right,
You understand my point?
right,
So
right.
it's trying to say that thing only to you,
Okay.
means on a other side, the
Ah,
system must decide whether to allow,
hello.
reject, or inspect the request before it's moved forward.
Ah, okay,
Okay.
okay, okay, okay. Right. Engineering view. Trust boundaries exist at points such as Internet to API gateway, mobile app to backend, external partner API to internal service, user browser to web application, one microservice to another microservice, admin interface to sensitive business operations. Okay, okay, these are the test boundaries. Okay, fine, got it. Okay, right. Okay, every time data come upon the boundary, the system must apply verification protection. Okay, example, a mobile app sends a request to update order status. The backend must not trust. Okay, user identity automatically, request payload automatically, device automatically, claim tool automatically. Okay, must not trust, right? The system must validate token, permission, request, structure, and allow the action before applying the changes. Okay, right. Okay.
Now
That's
you understand?
yes. Authentication and authorization. What? Authentication is basically who an entity is, while authorizing determines what the entity is allowed to do. Right, correct. Okay, fine. Why? Confusing authentication with authorization leads to privilege escalation and data leaks. Yes, rightly said. Correct. Okay, when at every point to the system and before sensitive operations. Correct. Okay. Use case. A delivery partner is authenticated as a valid user, but authorized only to update assigned orders. Yeah, he can't modify, for example, payments, right? Okay. Plain English understand. Authentication answer, who are you? Authorization, what are you allowed to do? Right. Okay. A person may successfully log in, but that does not mean that they should access every screen, every API or other piece of data, right? Engineering view. Authentication mechanisms may include username, password, session-based logging in, right? Okay, it come down. Yeah. Then JWT. About JWT, what is JWT? Deepak?
Java Web Token.
Oh, okay, Java tokens. Okay, fine, right. Or access token, authorize. Okay, auth based sign-ins. Okay, API keys, mutual TLS for services. Okay.
So basically, it's a token because, as I told you, means it contains all the information to the user.
Ah, ah,
Okay,
ah.
like what is the role, what is the email ID, what is the you can say name, and
Mm,
what are the organization. Means it contains. We cannot means use this token in
mm.
a plain manner.
Ah,
So
ah.
that's why we use this JWT web token. Let me show
Okay,
you how it will look like
okay.
and what you will see
Ah,
here. Okay,
ah.
so that you know. So this is a website, JSON web token. So
Right.
this is a token. Okay, if
Oh.
you will check this after you can say this is an encoded one, and
Mm, mm.
all these color have you can say meaning,
Oh, okay.
and you are able to see this is a data.
Okay, okay,
Admin is true and this.
okay.
Okay, so means it contain everything and you will means pass this in a header for
Ah, ah.
authorization.
Okay,
Okay.
all right. This is how it is. Okay, okay. Then GDPR access control, auth based. Sorry, I keep hearing that AUTH or OAUTH based sign-ins. Can you just give a small brief on that?
Yes, because OAuth have a you can say have a standard.
Ah,
So means OAuth have a community which have a standard of authorization
ah,
which you need to follow.
okay.
Okay, like these are they have a version or thing
Oh, okay.
with the help of that they will define.
Okay.
Okay, so you can think of these things. So they will define this
Oh,
means what you
using
need.
standard. Okay.
Yes, so it have a also standard and maintain that standard.
Uh-huh.
And based on you can say patient security or things are changed, then they will update their standard as
Uh-huh.
can see means how what is the structure of your access token, what is the
Uh,
how they will refresh, what is the scope there. So they will decide each and everything. You
okay.
understand my point? And where you
Uh-huh.
are able to see this.
Right. Okay.
Because someone is there who can monitor and update the things if
Mm-hmm.
required.
Mm-hmm. Mm-hmm.
Because we learn.
Correct.
It's not a
Yeah, right.
one-time effort. It's
Not
a
21.
continuous.
Yes, correct.
Same thing here.
Yes. Okay, API keys, yes. Then mutual TLS, TLS transaction, TLS, mutual TLS for services. Okay. For an authorization mechanisms may include role-based access, correct? On based on the role, whatever access we want, we can give. Okay, fine. Lowest staff level can only view. The next level may be able to add. Some other set of people can be able to modify the data. Okay, so authorization mechanisms may include. Okay, fine, right.
So
Okay.
TLS is nothing, transport layer security.
Security. Okay, networking. Okay, fine.
Okay, so
Right.
in this means we use standard, you can say some versions are there for
Ah,
TLS, and
okay.
we use a standard, you can say cryptographic protocol. It's a
Okay.
standard cryptographic protocol.
Okay. Okay.
Communication over
Ah,
computer network.
okay. Okay.
Okay.
Right. Okay, okay. At the end of chapter, one doubt I was having, like, let's say, no, we encrypt the data. When we encrypt the data and store it, if somebody hacks it, he will be able to unable to read the data. Fine, that is okay. But now, when the data is encrypted, if I write a query, if I'm writing a simple query, so now will that be decrypted and then record be selected? So will that cause a delay in my output, or how, Deepak?
As we means no
Ah,
trade-offs are there.
okay, okay, okay. Trade
You
off.
understand my point?
Ah,
Definitely, if you will means applying a checkpoint, then delay is there.
that's what I'm wondering. Okay,
You understand my point?
okay.
If you not means if you will want a speed,
Ah,
then you need to compromise with the security.
ah,
Because if you are applying a security on each and everything, means
ah,
you need to require some time
yes.
for that checkpoint.
That's what. Yes, yes. Okay, okay, fine, right. But I think big companies definitely will be encrypting their data, right? All the payment services, everything is encrypted.
Yes, means yes, that's why requirement gathering and understand the project scope and everything is important because though from that's a starting point from
Ah,
everything is initiated from there. If
okay.
you don't know the things at
Ah,
a requirement phase only, then you are moving towards a wrong direction.
okay, okay, okay,
You understand my point?
okay, 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 okay. Right.
Client expectation, client boundaries, you need to each and everything need to
Hmm.
know.
Hmm. Hmm. Hmm.
What are the limitation, client budget and everything,
Okay, okay.
and what client want.
Okay.
Okay.
Right, right. Okay. Role-based access control, yes. Attribute-based access control. 1 minute. Role-based, I understood. Attribute-based access control means what, Deepak? Attribute.
So right now, let's say you have a, you can say what is attribute? Attribute, let's say we are human being. And if you talk about our attributes, name,
Ah,
email, or you can say this, yes, designation, these are attributes.
okay.
Like name,
Ah,
whatever you can think of a class.
ah,
Class have a, you can say properties and behavior and
okay.
code. So when we talk about properties, which will have their own, let's say, car have a, you can say company, which can
Okay.
be very right, or
Ah,
car have a model which can be very, or car have a cost which can be. These are the attributes. Okay, of that car. So means you have a access on a particular attribute.
okay, 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 okay.
With the help of that, we are defining the access control. This is called attribute.
Okay, 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 okay. Fine. Then permission matrices, okay. Then resource ownership checks, right? Then policy enforcement, okay, okay, right.
What you
Mhm.
understand from policy enforcement?
No, so for example, we have a policy in the company. Let us say now, a person, let's say in simple, accounts department, one person, say a junior level person is can authorize payments. For example, say anything within 5,000 rupees, he is able to authorize that yes, it can be bought. Uh, Next level of persons can authorize somewhere between 5,000 to 10,000. So like this, I have a policy in the company which states that each person's how much is they can approve of. That's a policy of the company, but that varies from company to company.
Yes, which will define what user can do, what
Yes,
user cannot do, and what is the rights of that user.
yes.
And based on that, when something is happened, first they will check.
Hmm.
Means, hey, this
Right.
user have this access and have a rights or not.
Ah,
Then they will allow to
ah,
the user.
right,
Am I right?
right, right.
And because these are the important things, that's why in a cloud, each and every cloud provider take
Ah,
care of this and give
ah,
a provision to define this.
okay, 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 okay. Okay, authorized to view only assigned, yeah, sorry, authenticated as a valid platform user, authentic, or then authorized to view only assigned deliveries, correct. Not authorized to access customer payment, not authorized to cancel restaurant side orders, correct. Yes, example, fine, fine, fine. Oh, is this the delivery agent? Okay, I got it. Okay, fine, right. So this separation is essential for safe system behavior. Yes, very clear boundaries we are setting there, correct. Oh, least privilege. Least privilege means granting only the minimum permissions. Ah, yes, required to perform a task. Yes. Why? If an account, service, or token is compromised, they have limited permissions, reduce the blast radius. Correct. Yeah. Okay. Okay. Got it. Okay. Whenever defining roles, permission, services, accounts, or access point. Okay, okay, so whenever defining the roles, permission, services, service accounts, or access policies. Okay, fine. Okay, plain English understanding. A user or service should not only get only what it truly needs, nothing more. If too much access is given, just in case a mistake or a breach becomes much more dangerous. Correct. Engineering view. Least privilege should apply to human users, admin, internal services, background jobs, databases, cloud resources, CI/CD pipeline. Okay. Example, a notification service should be allowed to read message templates. A notification service should be allowed to read message templates, send notification, read minimal order event data, right? It should not be allowed to update payment status, correct. Modify user profile, query full customer financial information. Yes, correct. Records, correct. Data protection considerations. Okay. Data protection involves safeguarding sensitive data at rest, in transit, during processing. Oh, beautiful. At rest, in transit, during processing. Yeah. Okay. Why? Data breaches cause loss of trust. Correct. Loss of trust, legal consequences, and business damage. Definitely. It is happening. Yes. When? During data modeling, storage selection, and integration design. Okay. Use case. User personal details and payment data are encrypted and access is restricted to authorized services. Correct. Plain English. Sensitive data should not be openly readable by everyone, every person, system, or person. Data must be protected whenever it leaves. Okay, wherever it lives, wherever it moves, and wherever it is used. Okay, right.
Understand my point?
Yeah, yeah, yeah. Well, very, very beautifully put. Okay.
Because as I told you, security is a thing which you need to take care
Ah, yes.
on each and every point.
Yes.
You can think of if your house is secure, but
Ah,
your car is not secure.
yeah.
Okay.
Correct.
And wherever you are moving,
Hmm.
uh, mall or market, if it's not secure,
Mm,
then
correct. Yes.
you understand my point.
Yeah, 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 yeah.
So each and everything you need to think,
Yeah, I think.
and you need to think for each and every aspect. Like
Ah,
earlier, we think about we need to go with the modules, am I
mm,
right, and sub
ah,
modules,
ah,
and we need to think about failure and error as well.
ah,
And now we are discussing about the security.
yes.
So, but thumb rule is same. You need to first identify the boundaries
Right.
and identify the roles and there is and how things are moving from here and there. Then you can apply this.
Okay, okay, okay.
And the go means divide the system into a small, you can say, module, and then what is the role and responsibility of that module, and what is the ownership of that module. Am I right?
Right.
And after ownership, how what means what is the, you can say, relationship of that particular module with other module, how they will share the data, what data it will share, and what are the importance of that data.
Okay,
So
okay.
in a company, they will apply a different, you can say, these flags are there. This is a public, private, am I right?
Okay.
And you can say restricted. So based on that means based on your access, you are able to get that. Am I right?
Right,
Public,
right.
anyone can access because it's available publicly. There is no issue. You don't need to
Right.
consider any, but you can say, and you have this your own data. So you are owner of that data,
Right.
and if it's not related to business, then you can share with others.
Ah,
But if business involved,
ah,
then you can say you need to take a special care. You cannot share with your friends and other person, am I right?
okay, 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 okay.
And if you can say ISA means business B to B, business to business, then it should be, you can say, disposed or you can say shared
Okay.
with the authorized person. You cannot
Ah,
share with your friends or family. No.
yeah, correct.
So every label have their own importance, and
Mm,
to protect the data have is changing uh, based on this. Means
mm,
for business related data,
ah,
we need to, let's say you are means in a business meeting, you will representing something and you will write something on your board,
okay.
whiteboard with a pen, and you have some printout.
Ah,
Okay,
ah,
so as a because it's a business critical data,
okay.
you need to wipe out that board. Okay,
Ah, ah,
and if there are hard copy, either you will carry with you.
okay.
Okay, don't left there only.
Right, 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 right.
Okay, as well as if you want to destroy it, then
Mm,
destroy as well. There is some mechanism.
mm,
You
mm, mm.
cannot just throw those paper onto a dustbin
Ah,
directly.
ah,
No, there
mm.
is a process with the help of that you need to follow that process and destroy those things.
Okay, okay.
And while trans means moving, you can say there's data from one place to another. There is a, you can say, defined rules are also there.
Ah, ah,
Understand my point?
ah, ah, ah.
If you need to define, then it should be wrapped in a proper manner.
Okay, okay, okay.
Okay, either it's a system, it's a pen drive.
Ah,
There's some rule.
ah, 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 ah,
Means
ah.
you need to put in a one box and you need another box is there where label is mentioned about this thing,
Mm, 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 mm.
and it should be means go in a proper manner with a
Right.
ceiling should be there, and what is the measure of that ceiling, everything is mentioned clearly.
Ah,
You understand my point?
okay, 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 okay,
And for, you can say, your because data is everything, they will provide a, you can say, bulletproof laptop to the user. You can say senior level, they will
okay,
provide a bulletproof laptop.
okay,
You understand my point?
okay, okay.
So I'm just saying the scope of everything, whatever you're learning is, you can say, vast. So,
Okay, okay, okay,
okay,
okay. Right, right.
okay, go ahead, please.
Okay. Then masking sensitive data in logs, right? Masking that information, and then secure backups. Yeah, secure backups, and then key rotation. That is key rotation is AP key rotation or general key rotation is talking about, Deepak?
Yes, sir, you can say, let's say you are using some encryption key,
Ah, ah, ah.
because for encrypting and decrypting data, we can use some keys.
Okay, okay, okay.
For that, it should be rotated. If
Okay.
let's say that key someone breach, am I
Ah,
right,
ah.
or
Right, right.
compromised, then
Correct. Got it, got it. Okay, okay. Fine. Then sensitive data examples. Okay, fine. Come down. Personal information, address, identity, identity document, access tokens, internal business secret. Yes, these are all sensitive information. Example, in a food delivery, customer addresses are encrypted at rest, correct. Payment details are tokenized or handled by a payment provider. Logs do not expose full card or personal identity information. Only authorized services can read profile data, right? Okay, encryption at rest and in, oh, this is nice. Encryption at rest protects data, stored data, while encryption in transit protects data moving between systems. Right. Okay. Why? Without encryption, attackers or unauthorized users may tap, right, read unsensitive data directly. For databases, storage system, backups, APIs, internal service calls, and remove completely. And external integrations. Okay. Fine. Okay. So for database storage system, fine. Plain English understanding. If data is stored without protection, anyone with storage access may read it. If data moves across network without protection, attackers may intercept or modify the data. Yes, correct. Okay. Engineering view. Applies database files, file storage, object storage, backups, persistent disks. Okay, fine, right. Encryption transit. Yeah, very important. HTTPS for client server configure traffic, a TLS transaction layer system for service to service calls. Okay, encrypted messaging channels. Okay, secure partner integration. Okay, okay. Example, a restaurant payout file stored in object storage should be encrypted at rest. Okay, fine. Yeah. A request carrying order and customer details from mobile app to backend must be encrypted in transit. Yeah, correct. In transit, this is at database level. Okay, fine, right. Secure communication ensures data exchange between companies is confidential and tamper-proof. Yeah, I think example WhatsApp is every time they say no end-to-end is encrypted. When I'm sending a message, even if somebody is trying to tap that message, I think they cannot read it.
yes,
Okay, it's why insecure communication allows data interception, spoofing, and reply attacks. Correct. Reply attacks. Correct. Right. When for all service to service and client to service communication. Okay, fine. Use case. Backend services communicate over encrypted channels and validate service identities. Right. Okay. System should not just send data. They must prove who they are, protect the message while it travels, and ensure the message has not been altered. Okay. Engineering view, TLS HTTP certificate validation, service identity verification, request signing when where needed, replay protection where relevant, secure session management, timeout and retry policies that do not weaken the security. Yeah, correct. Yeah. Example, like order service sends a request to payment service. Connection uses TLS. Payment service identity is verified. Request contains authorized service credentials. Response is accepted only from trusted service identity. Okay. Service to service authentication. Service authentication verifies the identity of the internal service before allowing access. Right. Why? Internal networks are not inherently safe, and compromised services must not gain unrestricted access. Correct. Whenever one internal service calls another. Okay, fine, fine. Plain English. Just because a request comes from inside the company network does not mean it is safe. Every service should prove identity before receiving access to the internal functionality. Beautiful. Engineering view. Common approaches include mutual TLS, short-lived service tokens, yeah. Then service identities from workload platform, API gateways with policy reinforcement, signed internal requests, right? Example, delivery service calling order service should present a trusted service identity. Order service should verify which service is calling, whether that service is allowed to request its operation, whether the request scope is limited correctly. Okay, okay. Right. Designing, yeah. Okay, okay. A secure API enforce identity verification, permission checks, validation, safe communication. Why? APIs are direct entry politics into system behavior and data. Okay, fine. Whenever exposing functionality to clients, partners, or other services, yes. Okay, plain English. An API should never assume a valid looking request. Okay, should never assume a valid looking request is safe. Every request must be checked for identity, permission, structure, and allowed intent. Okay, fine. Engineering view. Security API should include authentication, authorization, validation, rate limiting, request side limit, auditing, logging, error handling without leaking sensitive internals, security for the idempotency for critical operation, data filtering based on caller permissions, right? Example, an order update IPA should verify the user is authenticated. The user owns the order or is assigned to it. The question is state transition is valid. The input payload is structurally correct. The caller is not exceeding rate limits. Okay. Security and system reliability. What security directly affects system reliability because attacks, abuse, or insecure design can interrupt normal structure system behavior. Correct. Why? Security incidents can cause outages, performance degradation, and data loss. Yes. When during architecture, design, scaling decisions, and operational planning. Beautiful. Okay, plain English. A system is not today reliable if attackers or misuse can easily take it down, overload it, or corrupt its data. Right. Engineering view. Security supports reliability through controlled access, reduced attack surface, rate limiting, blast radius reduction. Okay, auditability, then secure failure handling, isolation between components. Right. Example, if AP lacks rate limiting and validation, attackers may flood it, yeah, with requests, making it unavailable even for legitimate users. I think this in one of the company happened, and then they came to know that somebody is unnecessarily, making it unavailable for other users. Okay, right. And security with and scalability, yeah, very important. Security must scale with system growth without becoming either a bottleneck or a weak point. Correct. Why? Poorly designed controls fail under traffic growth or bypass under operational pressures. Correct. When? Okay, when scaling uses services, APIs, teams, or integrations. Okay, okay. Plain English. As system grows, security cannot remain manual. Okay, inconsistent or dependent on human memory. It must become a part of the architecture. Okay, right, right. Engineering view, scalable security requires centralized identity system, consistent policy enforcement, correct, automated secret rotation, service defaults in platform, reusable authorization pattern, observability for access and anomalies. Okay. Example, a platform with many services should not hardcore separate and ad hoc secrets everywhere. Yes, it should use a standard identity and secret management system. Okay. This is a visual train, touch train, access flow. Okay, it diagram. Okay, fine. Okay, flow again, flow chart, something. Okay. Ah, okay, incoming request, authorization check you're doing, valid identity, allow him, authorization check. Valid identity, reject the request. Authorize once it is authorized, then allow action, allowed action. What the allowed action is process request. Not allowed is they can deny the access. Okay. Data protection, okay, sensitive data, encrypt at rest, encrypt in transit, restrict access, mask in logs, then audit this, okay. This is a very common mistake, correct. Trusting internal traffic automatically. Internal services or networks are often assumed safe, which creates hidden risk. Yeah. Mixing authentication and authorization is very clear, that is clear. Okay, fine. Giving broad permission. Yeah. Fine. Sending sensitive data without encryption, oh, very dangerous, very, very dangerous. Exposing too much in API responses, that's correct. Logging secrets or sensitive data. Okay, log becomes secondary, which goes, yeah, true. Okay, no service identity violation. Internal service calls were accepted without proving caller identity, right? Weak boundary while validation system trust client separate roles, IDs or object connection without checking. Yeah, this is a common mistake you're doing. Okay, fine. Right. Okay. These interview questions. Okay. Okay.
Summary.
So beautiful. System level security distributed systems comes from defining trust boundaries clearly, verifying identity properly, enforcing least privilege access, protecting data everywhere, and securing every communication path. Oh, yes, yeah. But yes, yeah, we read it out, but implementing, I think, is a huge task here. I think everything we should take into account, and then whatever is appropriate at that level, we have to keep on doing it, right, Deepak?
Yes. So for that, mind shift is required.
Ah,
Am I
okay.
right?
Ah,
Mind shift is required.
hmm.
So that you think that first you need to think of that level, then you can implement.
Ah, okay.
If you don't able to think how you can implement.
Ah, okay.
And so we are learning those steps,
Ah, okay, okay, okay.
what we need to take care and how we can take care. But the thumb rule you need to decide, you need to think 360.
Ah, yes. Okay.
Okay.
Okay, okay. Right, right, right.
And need to check what means it's secure. Is could I divide into more chunks
Ah,
or responsibilities are clear?
ah,
Okay.
okay.
What is the responsibility, what is the role is there? So means if you will just think like a normal thing,
Uh,
then you will do this very easily. If you will make it complicated and things in a technical level, then it's a hard.
yes, yes, yes.
Trust me, it's hard for you then.
Right. Uh,
Just correlate with the normal thing.
Okay, 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 okay.
Am I right?
Right, 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 Deepak. Got it, got it.
Let me stop the recording.